Hi, good morning, everyone. I'm Kamini Santanagopalan, Product Line Manager with Broadcom Core Switching Group. And I have with me Adam Young, Software Engineer Manager with Broadcom as well. And he is the subject matter expert for the data center EVPN VXLAN topic about which we are going to talk about today. So to begin with, we'll talk about how Broadcom's engagement in the SONiC community has been, and we'll also give you an overview of the use case, what it entails, and then we'll talk about specifically VPN VXLAN contributions and get into the deep dive mode. We'll take questions towards the end of the session. Next slide. So Broadcom, we have been innovating across the entire stack. If you think about how it started, from 2016, we have been innovating in the SI layer. We have been contributing a lot of SI specifications and implementations to the community. And over in the last couple of years, like 2018, 2019, 2020, we are also adding a lot more value in terms of the other layers as well, routing, be it routing protocols or management protocols or other stack as well. And if you look at the team, so we have a very strong engineering team with a very deep expertise in NOS and delivering NOS. We have also hired engineering leaders who have proven expertise in delivering enterprise class network OS. And as I said, we have enabled new use cases such as the multi-tenancy using BGP, EVPN, VXLAN, and we'll talk about it in detail today. And our goal is basically to enable the open source NOS to move at the speed of silicon innovation, for which Broadcom has been a leader and known for. And internally, we also are fully aligned and committed on SONiC as the NOS of choice and qualification of SONiC with SI as an integrated solution. All right. So going to the next slide. So as you can see, this is a very busy slide. So here the point I would like to highlight is you can see the detailed list of PRs for yourself. And we have some that are already merged, some that are submitted and going through peer review process right now, and few that are yet to be submitted. Here again, the idea is that Broadcom has been innovating and contributing to the SONiC community all along, and we continue to deliver so many features within SONiC. Coming to the use case, so the VXLAN overlay network design, basically in the data center, allows the end users, that is, it could be the network admins or whoever is configuring the networks, to extend their layer 2 and layer 3 networks over a layer 3 underlay, your BGP underlay. So with this, essentially what happens is the endpoints, the servers or the virtual machines, you can place them anywhere in the network and still be connected on the same logical network. That's the whole idea. And if you think about it, there are three key things to keep in mind with this solution. So one is it provides scalability. So here, of course, by using VXLANs, you get a larger number of VNIDs compared to VLANs, and this helps in future proofing the scale-out architecture. And while originally designed to use a flood and learn mechanism to learn and distribute the endpoints, VXLAN has since evolved to use your control plane protocol, like a very mature control plane protocol like BGP EVPN, for distributing the endpoint information. So over the years, this has become the preferred method of deploying VXLAN, as it basically reduces unwanted flooding in the network. And this is the method we also prefer, and this is the method that we have also implemented. And when talking about flexibility, so this design allows, as I said, you can extend your L2 network over the L3 underlay. This means that your host mobility is achieved. So you basically, your endpoint can be placed anywhere in the network, as I said, and can still remain connected on the same L3 underlay, same logical network. And here the use of overlay also, decouples the logical topology from the physical topology. And this simplifies your network design by originating your VXLAN from the first hop switches. So you don't need to run any STP across the data centers. And how do we achieve multi-tenancy? So the multi-tenancy support is achieved by the VXLAN segmentation. VXLAN supports both L2 and L3 in the overlay, allowing both routing and bridging between the servers or the VMs. And it also reduces the number of state that is present in the network, and thereby eliminating the need for devices having a very large routing tables, like even at spine layer. And by having a broad L3 ECMP, you can easily provide load sharing and redundancy that is much needed in the underlay. And then coming to the open standards, as I said, here we are going with all standards-based solution, and Broadcom's implementation is based on RFC standards 7432 and 8365 based. We are not deviating from the standards, neither are we introducing any proprietary stuff. On top of all this, we also provide programmatic APIs for easy provisioning and monitoring, like attaching to your northbound orchestration tools. And I think the whole thing will be easily viewable if I go to the next slide that shows the diagram actually. So basically here, all we are saying is your tenant separation is achieved, and your L2, you can extend your L2 over your L3 underlay here. And also your VXLAN tunnel, you can start from basically the tunnel origination is and termination is depicted here. So different tenants can use the same physical infrastructure and get segmented. So tenant A can function without having to worry about other tenants' existence. Okay. Okay, and here, as you can see, we are doing a lot of northbound integration via CLI or SNMP, or it could be GNMI or REST APIs with Open Config YANG models. And we do have integrations with some of our key partners I would like to highlight here. And we do have integrations with the provisioning orchestration tools such as the Abstra, and also we have integration with the monitoring analytics tools, that is the AI ops tools from Broadcom. This was originally CA Technologies, now part of Broadcom. I would like to pause here and let Adam continue. So as I said, he's the SME for VXLAN EVPN, and he has tons of experience with this, and he will get into the deep dive mode for now.
Thank you very much, Kamini, for going over the VXLAN use case. And from here, I'm going to take over and then talk about the design of the EVPN VXLAN and some of the bits and pieces that we have put together as a Broadcom contribution for the EVPN VXLAN solution. So first off, as Kamini has mentioned, I mean, the implementation that we have done for EVPN VXLAN is entirely RFC-based. Standardized solution. This is based on RFC 7432 and RFC 8365. We introduced the additional 2 BGP EVPN type to the SONiC solution. So we have bring in the type 2 routes, which is the MAC and IP host, and also the IMAP route, the type 3 routes to SONiC. So type 5 is already existing today to support the use case for VNet. So we are leveraging the type 5 for IP prefixes support as of what we're doing for the L3 services. And effectively, with these new BGP type, we are supporting the VLAN extension, which is the entire L2 traffic services over VXLAN. We are also supporting the VRF notion about L3 routings, and services over the VXLAN. Standing Anycast gateway is also supported in these particular contribution. And then we allow ECMP load balancing as well for the tunnel overlay. And then the implementation of a tunnel is actually modeled on ingress replication. So we don't have a underlay, VXLAN over multicast cases right now, but then the replication happens at the ingress VTAP. And then there are also multiple variations that we can support for underlay technologies. For example, RFC 5549, which allow a IPv6 underlay to be supported in the case of VXLAN, and also, of course, port channel. So here we're gonna look at a typical, IP fabric leaf and spine setup. So your server racks underneath your leaf layer, and then your spines here, it's actually a full mesh to all the leaves. Now on an L2 surface topology that we're talking about here, so the first thing happens is that there will be route exchanges, for BGP EVPN type 3 routes, which is corresponding for the IMAP routes that can be exchanged within all the leaf nodes. And then with these IMAP routes exchange across with the leaf nodes, there will be a VXLAN tunnel that get created for each of the VTAP, as well as we're going to set up for ingress replication for multicast next hop. Now, for any unknown unicast traffic, the traffic has to be replicated at the ingress VTAP. So for example, if there's a server rack actually sending a unknown unicast traffic entering into leaf end, it will go through an individual replication of these packets, and then going into each of the individual nodes via the multicasting hub. And then the source MAC is going to be learned on each of these leaf. So for example, the source MAC for this particular server rack is going to be learned by the leaf N, and then the learning of these MAC is going to be exchanged via BGP MAC routes, the type 2 routes, to all the leaves. If MACs that already being learned locally and remotely, then from that point onwards, is unicast traffic point to point. For example, if leaf N here, we actually got a known DA MAC that needs to travel into the leaf 2. This will be a direct. This will be a L2 traffic that being encapsulated with VXLAN tunnel, and then going directly into leaf 2 via the spine. So as far as traffic load balancing is concerned, there are 2 layers of load balancing. So on the leaf level, you'll be doing a hash, across the L2, L3, L4 header, and then basing on that, it's going to select the next hop. Now at the spine level, it will be load balancing basing on the UDP source port that is actually encapsulated, from the leaf node. Here we talk about, how the MAC is going to be learned, from the remote. So for example, if I have any MAC entries that picked up from a VTAP, coming as a remote learning. So this will be entering for FRR, going to the kernel, and then via the netlink socket, going to the switch SS Docker, and picked up by FTP syncd. FTP syncd is gonna install those MAC entry into the FTP. FTP org will be the subscriber of this MAC entry, from the FTP. He's gonna push it into the ASIC DB, and then from ASIC DB, it'll be picked up by the syncd and programmed to the side. For locally learned MAC, if I have any MAC entry which was learned locally by the ASIC, then it will go into the FTP org from ASIC DB. And then FTP org is going to publish those MAC entry in the StateDB, going to the FTP SIND. And then FTP SIND will do a filtering if this is actually a L2 VNI mapping of those MAC entry, then it will go into the kernel, publish into FR. And then from FR, it goes through BGP, type 2 route and exchange to the remote leaf node. Here we're going to talk about the L3 surfaces. With the L3 VNI configured, so the BGP is going to exchange with type 5 routes across all the leaf nodes. So it's going to create a VXLAN tunnel. There are, essentially 4 pieces of information that needs to be exchanged across the leaf nodes, including the prefixes that they have announced, within the VRR space. Their VNI mapping needs to be exchanged. There's also the VTAP, source IP that needs to be exchanged, as well as the router MAC, for that, VTAP SVI. The layer 3 traffic will go out of the unicast tunnel next hop and then, encapsulated with the VXLAN tunnel. Now, the inner packet, DA MAC will be the remote, VTAP router MAC address that we, exchange via the type 5 routes. And then the traffic, again, will be load balanced at 2 levels. So there's the ECMP between the leaf and spine. And also there's another load balancing from the spine level back to the leaf. So here we're talking about some remote ARP and ND coming into the local nodes. So of course, this is going through the FRR, coming from BGP route. And then these will enter into the kernel. Kernel will deliver those ARP and ND updates, via the netlink socket towards the neighbor SIND. Neighbor SIND is going to publish those into the FTP. And then neighbor ARP will subscribe to those updates and push it into ASIC-DB. Now for any locally learned ARP and ND, so it will be first picked up by the kernel, and then from there on we need to program our local ASIC. So it goes into the neighbor SIND, and then that goes to FTP, subscribed by neighbor port, and push it into ASIC-DB. So that way we'll have the local ARP and ND updated into the ASIC. And then at the same time, kernel is going to also update FRR via the Zebra, and then go out into BGP routes. So that concludes, the basic of the L2 and L3 surfaces that we have done for EVPN VXLAN. And then here's the link to the HLD for the EVPN VXLAN, coming from Broadcom. And then currently the code PR review is in progress, and then we're trying to enter the community code base in 2020-06. And then this is the mailing alias. So thanks so much for attending the meeting, and for any questions, we can follow up with the Q&A.
We are open for questions, and I see some of the questions flowing in through the chat window. So we'll try and answer it in the chat, and if something needs more explanation, we can go ahead and talk. I'll put myself on mute for now.
So we have some questions on the chat window. So one of the questions is that, what is the platform being supported today? So from Broadcom, we are supporting this on TD3 for EVPN VXLAN. Kamini, do you want to answer a question about the future roadmap?
Yeah, I replied in the chat window. I don't know if people saw it. So I can share the slides offline separately, mainly around multi-site DC interconnectivity. And we have quite a bunch of enhancements coming in the manageability infrastructure area, like open config yang support and a bunch of stuff. So I can share it offline.
So there's a question about VXLAN filtering based on VNID. So this is a BGP-based EVPN VXLAN solution. So there's L2VNI and L3VNI that, as a configuration task to basically allow the L2 VLAN extension as well as, VRF L3 VXLAN. So this is the VNI that we use to do the corresponding mapping between the L2 VLAN and then VRF mapping. Okay, I don't think I see any more questions. Kamini, do you have anything else to add?
No, not at this point. So does anybody else have any other questions for us? We are looking at the chat and QA window, and we're also on the phone. Adam, maybe we can wait for a couple more minutes.
Sure.
Take question. Yeah.
Yeah, so in response to the private version of SONiC, basically, the implementation for EVPN VXLAN, we are actually upstreaming, the implementation that we have to the SONiC community. It has to go through the GitHub, review process. This is already in place. There are about 8 to 9 co-PR that we submitted. The EVPN XLD, the EVPN VXLAN XLD is also submitted to the community. It's actually also under review. There are actually multiple sessions within the EVPN subgroup that we have gone through in terms of reviewing it, and then having that to be shared with the community. So, question about how to get additional info. I think the best way is to leverage the EVPN subgroup. So there is already a EVPN subgroup that I listed on this slide. So any questions, anything, or basically detailed discussion about VXLAN can go into that subgroup, and then there will be folks from Broadcom to explain some of the details, and also share the co-PR's info and all this. Question here is anyone actively testing implementation on TD3? Of course, it has been fully validated in TD3. We have a QA process in place, actually completed validating on the TD3 platforms for the EVPN VXLAN solution. Question on which version of SONiC will include EVPN VXLAN. So again, this has been submitted to code review. It's in the process of co-PR review to be merged. The intention is to actually pull into the 2020-06 release for SONiC, but then it all depends on how the review goes and what is the timing of this merge and all this. Okay, so we have come to the end of the session. So thanks everybody for joining the meetings, and again, the EVPN subgroup has a lot of information over there. I encourage anybody interested of doing this EVPN VXLAN solution to take a look at the HLD, take a look at the code that we submitted. We can go from there. Amini?
Thank you, everyone.
Anything else to add?
And I do see, for any other additional information, please feel free to reach out to us, Adam or Kamini or any of the Broadcom team members. We'll be happy to answer.
Okay.
Thank you.
Thanks, everyone.